So to finish out chapter 3, we are going to take a look at how matter can change. And so there are two ways that matter can change. They can have physical changes, or they can have chemical changes. So our first thing we're going to look at is the physical changes. And these are changes in one or more of the matter's physical properties. The substance in a physical change, the substance remains the same substance. It can change looks, but it does not change identities. Oftentimes, physical changes are easy to undo. So, for example, braided hair can be unbraided, melted chocolate could be cooled and rehardened to form solid chocolate again. And in each time, it's still hair and it's still chocolate, regardless of the physical change that it went through. So, some more examples. We have cutting. Cutting is a physical change. It usually just makes the object smaller, but it still maintains its identity. Here's your braiding hair example. Crushing a metal can. It's still a metal can, but it's just crushed. Windblown sand has created this structure here. However, it's still a rock. It's still the same identity. And again, here's your melted chocolate example. Chemical changes are changes in matter that occur when matter changes chemically into an entirely different substance. With chemical properties. These chemical changes, I like to think of as a little bit more showy or exciting than a physical change. So, for example, when we mix vinegar and baking soda, it bubbles and gets really fizzy and makes carbon dioxide gas. Excuse me. So with these chemical changes, we have some examples. When leaves turn color in the fall, this is because of chemical changes that are occurring in the leaves. Frying an egg, the heat changes the egg into a different substance with different properties. So if you notice the raw egg, the egg white is actually clear, but as it cooks, it turns into a solid white color. Some of these copper pennies are bright and shiny, like this one right here, while others are more dull. And this is because their copper has reacted with the oxygen to form a new substance with different properties. And then burning the logs in the campfire, it slowly reduces the logs to ashes, and the ashes are composed of different substances than the logs. Again, it has a different color and a different texture than the wood. So you can use these links to watch a couple videos about physical and chemical changes. When we have a chemical change, there are some distinct indicators that a chemical change is occurring. So the first one is that we have gas bubbles being released. The color can change, but be careful on this one because this can also indicate a physical change. So this one doesn't always tell you that it's a chemical change that is occurring. Often if there's an odor produced or a smell, it's a sign of a chemical change, or a precipitate is formed is another indicator that a chemical change has happened. So a precipitate is a solid that forms from a solution. So what that means is you take a liquid, combine it with another liquid, and what you're going to get is a solid. And oftentimes these solids are more powdery or flaky. Reversing chemical changes, they often can't be undone. So when you cook an egg, you can't get a raw egg back after it's been fried. You bake a cake, you can't get the cake batter back after you've put the cake in the oven. Chemical changes can only be undone by other chemical changes. So remember those pennies that some were shiny and some weren't? That's called tarnish on the penny. Sometimes that tarnish can be removed by placing the penny in vinegar. and then the vinegar is going to react with the tarnish. While we're doing chemical changes, we have to follow this law of the conservation of mass. And this says that matter cannot be created or destroyed in chemical reactions. So the total mass of matter always remains the same. So when we have a campfire, we have the mass of the logs, and at the end, that log is reduced to a pile of ashes. And so your gut is probably saying there's no way that a pile of logs and a bunch of ash weigh the same, and you would be correct. But you have to take into account the other things that are released from the fire, the carbon dioxide and the water vapor or the smoke. And so if you were to trap all that smoke and get the mass of that and add it to the mass of the ashes, it would indeed equal the mass of the logs in the campfire.